Hi, I am R. Venkatesh, Assistant Professor in Electronics and Communication Engineering Department at Rohini College of Engineering and Technology, Anjigramam, Palkulam, Kanyakumari District. In this topic, we are going to see overview of Solitons pulse in optical communication network. After the completion of the topic, student will be able to explain about the basic concept of solitons and the parameters that are used in soliton pulses. Introduction. So due to group velocity dispersion, which is caused, most of the pulse which is propagated through the optical fiber is broadened, so the information carrying capacity of that particular fiber signal is reduced. So to overcome this problem, solitons are introduced in optical communication networks. A solitons are the pulse that travel along the fiber without change in shape or amplitude or in velocity. So the term solitons refers to a special kind of waves that can propagate undistorted over long distance and remains unaffected after collision with each other. So solitons takes an advantage of nonlinear effects in silica, particularly self-phase modulation resulting from Kerr nonlinearities to overcome the pulse broadening effects of group velocity dispersion. In an optical communication system, solitons are very narrow, high intensity optical pulse that retain their shapes through the interaction of balancing pulse dispersion with nonlinearity properties of an optical fiber. So here there are two different types of solitons or pulses are used. One is fundamental solitons and another one is higher order solitons. The fundamental solitons are the family of pulse that do not change its shape are called fundamental solitons. In higher order solitons, the family of pulse that undergo periodic shape change are called higher order solitons. It's the change in the normal high intensity pulse of soliton pulses which is propagated inside an optical fiber channel. So here we are using a special solitons that are eliminating the scaling constant which is occurring by non-linear Schrodinger equation process. So here it will be eliminate three different terms. The first term which represents group velocity effects of a particular fiber. The second term which denotes the reflective index of the fiber depends on the light intensity. The third term which represents the effects of energy loss or gain of the particular signal. Next we are going to see the sonnet optical parameters. So in solitons which is used in optical networks, here we are using four different types of parameters. So one is full width of maximum, second one dispersion length, third one soliton peak power, and the fourth one soliton width and spacing. Full width of maximum. The full width of maximum of a pulse is defined as the full width of the pulse at its half maximum power level. So the full width of maximum of the fundamental soliton pulse is normalized time T naught is founded from the relation T naught is equal to Ts divided by 1.7627, which is approximately 0.567 into Ts, where Ts is the full width of maximum pulse width. And next we are going to see the dispersion length, L dispersion. The normalized distance parameter, which is also called as dispersion length, is a characteristic length of the effect of a dispersion term. So L dispersion is a measure of period of solitons and it's given by 2 pi c divided by lambda square into T naught square divided by T. So next we are going to see the soliton peak power. So soliton peak power is simply referred P peak. The parameter P peak is the soliton peak power which is given by A effective divided by 2 pi n square into lambda divided by L dispersion, where A effective is the effective area of the fiber core and the N2 is the non-linearity intensity dependent refractive index coefficient. So next, soliton width and spacing. In soliton width and spacing, consider if TB is the width of the bit slot, then we can relate the bit rate B to the solitons of half maximum width Ts, where B is equal to 1 divided by Tp, that is equal to 1 divided by 2 into S naught into T naught. The value which is calculating, which gives 1.7627 divided by 2 into S naught into T naught, where 2 S naught is equal to capital TB divided by T naught is the normalized separation between neighboring solitons pulses. Thank you.